In this tutorial, we are going to look at exception handling that refers to runtime errors. When program deals with runtime errors, then normally it terminates abnormally. So there should be some way to continue our operations or terminate it gracefully. Again, here, let me show you an example. What I mean by we can continue its normal operations. So let's say calculator. So normal operations like this, you say 10 divided by 2 is normal. We clear and say 10 divided by 0. Here say cannot divide by 0, but we can still continue use calculators, isn't it? This is the idea of exception handling in practice. So we are learning that idea of continuing our operations even though there is an exception or runtime errors. Exception handling, we need to do roughly 3 steps. Sometimes we have to go for 4 steps. The first one is, of course, we have to declare exceptions. We can throw exceptions, and we can catch, so that we can do what we want with exceptions. That's why we call it as a processing exceptions. Catching, processing exceptions. Let's look at exception types. It is actually the hierarchy of exception class. There are so many, but I will try to focus on most common classes related to exception handling. So we have an object class, and the subclass is throwable. And here is the exception. Actually, when we're referring to runtime errors, we have an exception and error class. On the exception class, we have class not found exceptions. That may happen when you deploy your program. And then IO exceptions. Again, that refers to input and outputs. And then SQL exceptions is related to database. Whether we have a database collection or not. Runtime exception, again, that's the most common ones. So we have error. Let me move a little bit down here, and then let's make it as a class. So for class, throwable subclass, and the exception has multiple subclasses. Most popular one at this point is class not found exception and IO exception, and most important thing is runtime exceptions. So it's extend object class, exception extend throwable. That means we should be able to throw exceptions. Okay. Error also extend throwable class. So IO exception, SQL exception, runtime exception. Okay. or extend exception class. So we have a file now found exception on the IO exception. And then on the runtime exceptions, we have asymmetric exception, null pointer exception, indexed out of bounds exception, illegal argument exception, and then input mismatch exceptions, reporting to data type, and so on. So let me make it as a subclass of runtime exception. Then all extend runtime exceptions. And then index out of bounds exceptions. There are popular exception handling as well, what we call it as array index out of bounds exceptions. Let me move it down. And then there's another exception referring to index when we manipulate the string. Okay, so it's coded as a string index out of bounds exceptions. Like a character add or substring, when you use it, that may happen. Most of them are subclass of index out of bounds exceptions. And then there are two concepts related to exception handling. Something we can handle by ourselves, or something we have to handle. Or I will say your compiler, our compiler, force us to do something about it. So here we code it as unchecked exceptions. There are two of them, runtime exception and all subclasses. And the error. And then everything else we code it as checked exceptions. Everything else in without green circle. That means that compiler force the program to check exceptions and then deal with the exceptions. Normally there are simple syntax we can use, catch and try and catch block, or we can declare at the beginning in the method header so that we can deal with that. That's the most common way of using exception handling. Okay, let's create a new project. I'm going to begin with a simple example. Saying that we have two numbers. Normal operations like number 1 divided by 2, then result assigned to answer, so that nothing will happen. Which is good, okay? So let's say answer is answer. Here answer is 2, which is good. Let's change to 0. Okay. They bring us arithmetic exceptions. It says that Java language arithmetic exception divided by 0, which is now allowed. Okay. There's a stack tracing, additional information next lines. Don't worry at this point. So that's something to do with arithmetic exceptions. Okay, at least when you learn it, you see name of the exceptions. Okay, we can actually avoid this problem using simple if-else statements. So we can say that if number 2 is not equal to 0, then we do what we like to do. We try to calculate it and then assign the value. Otherwise, we just print a simple message saying that divisor cannot be 0. Sorry, E. I think I have to remove one. Okay. So you say divisor cannot be 0, answer is 0. Which is not entirely correct, but still it does not terminate program. So that's what we want to, we like to do. Same as using Windows calculator. Let's comment it out. Try to learn to use exception handling. So let's say very simple one, try and catch. It works exactly the same as if and else. That's, we focus on if, what we like to do. So we say try to learn that statement. Then if exception happens, we catch that exception. Name of the exception, arithmetic exceptions. It's not difficult to find out the exception because when that happens, it will appear on screen. So say EX, because arithmetic exception is a class. Instead of dealing with the exception directly, I will say system print ln. This is how I'm going to deal with the exception. Just print our own message. Divisor cannot be 0. This is what we call as handling the exception called arithmetic exception. This is how we catch. Try, that's how we declare exception handling at the beginning. So let's see what happens. Can we actually reach the line number 9 or not? So yes, it handles exceptions. Still continue our program so that we can see answer is 0. So this is actually better approach. So when that happens, unusual things happen, what we call as exceptions, we can handle it. Then we can continue to run our program. That's the idea of exception handling here. There's another way of using exception handling. We can declare exceptions handling in the method header. Usually, this is not as effective as using try and catch, or eventually we'll learn try and catch finally. many cases it's good enough because it's simple to use, okay? So let's say we have one method called quotient, number 1, number 2. Here, let's say public static void quotient int number 1, int number 2. And we can focus on try and catch, but we will focus on only what we like to do. So next to this method header, we can throw name of the exceptions. So when exception happens, we can handle it up with this in the catch, or we can just read away. So this is what we want to do. Say if it's 0, then the divisor cannot be 0. Return number 1 divided by number 2. Then should be return type int, sorry. System out, println, print. Again, it's not going to catch the exception, okay? We'll just throw it. And we won't be able to handle it. So divisor cannot be 0. Again, exception happened. We did not deal with it. So it's usually a good idea to have a try and catch inside the methods. But for simplicity, I didn't do that. So you can see the difference between try and catch, or you can throw exceptions with the method header. This is a better approach. So you should have a try and catch. Let's just continue. I did not record the first part of arithmetic exception, which is exactly the same. I just want to copy paste it. Next one is null pointer exceptions. We know that when we try to print something you don't have in reference value, then you have a null pointer exceptions. Just quickly show you most common exceptions may happen when you learn programming, okay, in Java. So index out of bound exceptions has array index out of bounds exception and string index out of bounds exception. Let's look at the array at this point, okay? So you have array size 5. Ideally, let's say list 5. It seems like that's okay. But we are referring to index number 6. When you say 5, that's a number 6. That doesn't exist. So this is what you're going to get, okay? Array index out of bound exception. That is subclass of index out of bounds exceptions. So let's try to use try and catch, or try to do exception handling so that we can do what we like to do. 2 lines, catch, number exception is already there. Okay, index out of bounds exception, you can use superclass, no problem. Let me just use a subclass. Array index out of bounds exception, I will call ex1. You can get message. They say return the message string of throwable. Okay. Can we actually continue until these points? Okay. Yeah, it continue. Okay. Sorry, I forgot to print. So we can deal with the exception. In this case, just print what's inside the exception, okay? Say number 5, okay? something to do with number pi, okay? You can use toString methods. It says that, okay, name of the array, and then there's number pi, okay? That might be more useful. Let's make a comment. So let's look at the second one, okay? Second example, what I mean by second one, okay? Let me move up so that I don't have to type it again. So here, null pointer exception, we can do try. That's what we want to do, catch. Name of exception happen to be a null pointer exception. Declare EX, okay. Here, I'm going to say EX dot, most popular one is toString, okay. Again, here, let's see what happens. Say null pointer exception, and we continue, okay. Normally, you don't want to print, you just catch it. So EX toString is okay without saying system out println. And the users, they don't have to see that, okay. Same string, something we already did. So we just say try and catch up to that point. Name of the exception, arithmetic exceptions, EX. Again, we are saying system out, but in practice, EX.toString is good enough because we don't want end users to see our error message, okay? But for practice here, we like to see that. So that's the message we have. We deal with that, okay? And we continue. So let me put some comments. So here, same story. This is what we call as a try block. This is a catch block. This is a handling. This is the way we are handling our exception, okay? So let me have a look. Catch exception seems okay. Seems okay. That okay. So here, quotients, we are throwing exceptions in the method header. Okay. So let me explain a bit more here to make it clear. Okay. So this way, it enables method to throw exceptions. And to each caller, in this case, quotient methods, so that it enables the caller, which is a quotient method, to handle the exceptions. Okay. This particular case is not effective as a previous one because we did not use try and catch, just through exceptions. Okay. Normally, that's what happens when you use IDE like NetBeans, Eclipse, or IntelliJ. It often generates the code with exception on inside the method header rather than try and catch. Okay. So at least you should be able to see that that is exception handling not as effective as using try and catch. So that you should be able to modify it to make it more effective. Okay, next one we are going to look at try and catch, and finally it is possible to have more than one catch. If you press Ctrl spacebar, arithmetic exception has a superclass called runtime exceptions. So once we do arithmetic exception, try to catch runtime exception. So within one try and catch, you can actually handle two different exceptions. This is not really practical ones because arithmetic exception may happen. It may label it to runtime exceptions. But just as an example, it is possible to catch two different exceptions. So here, it works as it is. The question is here, can we use runtime exception earlier than arithmetic exceptions? So if you're using a runtime exception, happen to be superclass of arithmetic exceptions, it is not necessary to have arithmetic exception. It says has already been coped. So when you cope according to some sort of a hierarchy, you have to use subclass, then superclass. So we know that we have another superclass of runtime exception, call it as exception. So if we call exception after runtime exception, it is possible to use that, okay? Of course, in practice, we may use different classes like IO exception, runtime exception, not within the same hierarchy, maybe different hierarchy. So again, it works as it is, no problem. So idea is it is possible to use multiple catch within one single try. So if we hide arithmetic exception, then it will lead to runtime exception. Same message up here. Same idea as polymorphism. Supertype can refer to subtype. Okay, it means supertype exception can handle subtype exception as well. So that actually works too. So main idea is you should be able to catch multiple exceptions using multiple catch phrase here. So if you look at line number 48, no matter whether there is an exception or not, we like to see answer is whatever. In that case, we can use a finally phrase here or finally statement. Instead of leaving it at the end outside the try and catch finally statement, you can actually combine together as a try what you like to do, catch certain exceptions. No matter what, we will learn this statement. That means after finally, we can state what we like to do, whether exception occur or not. So you can get the idea in practice. We may have a try and catch. Sometimes we catch more than one exception. Then certain things has to be done finally. So 5, okay. What if there is no exception? Is it going to be okay? We can change. That's the one. What if we have an exception? Still it works. No matter what, line number 40 leads to that line number 40. That's the idea of using finally, okay? So you can see the advantage of using try and catch finally. Normally, we use multiple catch when you're dealing with I/O. So I/O, maybe looking for a file to open, close. Maybe you are doing some calculation, maybe arithmetic exception. So you need a two exception handling for that. And maybe finally as well, to finalize your calculation, for example. Okay, that's all for today.